All right, so today I'm going to be talking about vibe coding, vibe testing. It's kind of the new terms that everyone's talking about, and how these AI-powered shortcuts can actually create new problems. So for those who don't know me, my name's David. I chair the W3C's Browser Testing and Tools Working Group. So this is the working group that kind of creates WebDriver, the WebDriver BioDie, does all the work with all the browser vendors to get things into a space that you can use it. I work on Selenium, I've written books, and now I head up the open source program office of BrowserStack, and also head up developer relations. So the agenda for today is I'm going to talk about the AI paradox that I think a lot of people are seeing, but don't fully understand. I'll talk about vibe coding, the rise of vibe testing, and some real-world pitfalls. And along the way, I will try to give you real-world examples, because I think it's important that it's not just theory, that we see what's actually happening out there. So in July this year, this story came out. 2 major AI coding tools wiped out their user data after making cascading failures. And I really like what Gemini said to the user. It was like, I have failed you completely and catastrophically, right? It was so, one of the first one that was, made it on there, so it was Gemini. The other one was Replit, right? Replit's getting a lot of good news at the moment for their work. And what Replit did was they deleted the production database for the person that they had created. It was all their sales leads, so suddenly they had no sales pipe, couldn't make any sales in their company, because the person who was doing it was vibe coding. And that's quite scary. We're all taught, never do anything in production. You have all these guardrails. But the world of vibe coding and things like that is slowly but surely eroding the guardrails that we've set up for years, maybe even decades, to protect our users, protect our data, and protect our company. So the AI paradox is speed versus substance. So if we look at all the tools out there, Gemini, ChatGPT, Claude, things like that, the speed that you can write code at nowadays is unprecedented, right? We saw Hamza's graph earlier of the rise of AI, right? How quickly it is going up that way, and how quickly it is kind of democratizing all the roles that we can do. And suddenly, we've got rapid prototyping. And as we all know, prototypes go into production and then they stay in production forever, right? We then have to fix them. And the speed is phenomenal, right? I'm sure we've all been following the work that Jason Huggins is doing about Vibium, right? His vibe-coded Selenium. And all the work that's going on there. And it's moving so fast. But the problem that comes with it is suddenly we lose all understanding of what is happening underneath the code. Suddenly we can write code very fast. We have people who have written code really fast, but they are product managers and don't understand how the code works. They are designers who don't understand how the code works. In the same way that, and this is going to show my age, when I started in the industry and I was using Dreamweaver to build websites, I had no idea what the HTML would look like. And then as I got better and I looked at it, I was horrified, right? And suddenly, the foundational knowledge that we all need is gone. Right? We have moved our thinking into another tool at the expense of speed. at the expense of being the first to market, the first to do anything, which I think is really important to make sure that we understand this. So I've done a talk in the past where Selenium is not the reason why your tests are flaky. The reason why your tests are flaky is because you don't understand how browsers work or your application works. And it's not your fault, because we've been taught to focus on the tooling, the frameworks, the next step. Understanding, getting that foundational knowledge becomes the thing that you need to do next. So, vibe coding. For those who don't know what vibe coding is, it's kind of writing or accepting AI-generated code. And you just ask a prompt, I would like you to build out this feature, or I would like it to look like this. I vibe code mostly around things that are front-end, because I understand the fundamentals of CSS, but I can never get the positioning right? And so the code kind of starts to feel right, and I don't always spot the problems that are there, because it kind of is placed it in the right place. Going back to my Dreamweaver example, is that I've kind of, instead of being able to drag and drop, I just use a natural language prompt and go, hey, I want this over here now, please. And I want it to be mobile friendly while doing that. And the problem that we then kind of hit is that we stop anticipating failures. As testers, as developers, the problems that we always tend to focus on is the happy path. Testers then have this unique and amazing ability to find every edge case. They find race conditions, they find obscure bugs that no one ever thought of. And as I put at the bottom there, if you don't know why the code works, you won't understand why it fails. You don't have that fundamental knowledge underneath. And going to kind of back to edge cases, right? As testers, we know that there is no such thing as an edge case, because everything suddenly becomes an edge case. We can change our code, we can do things like that, but the edge case will still be there, or we just keep adding if loops, or if statements. So, I've talked about the basics of vibe coding, and I keep seeing kind of the phrase being used a lot, which is, what is vibe testing? And vibe testing is this kind of incredibly reactive approach. Again, it's like, can I quickly write up a Playwright script, Selenium script, to do what I want? And the goal is always make it work, or make it work good enough, right? And we all have this kind of role in our jobs every day of kind of, the feature that we've been given needs to be released the next day, yesterday, things like that. And so we just go, well, it's good enough, and we should focus in on getting it right. But if we keep doing the bare minimum, or trying to focus on speed, we never make sure that our code is actually robust. Can it scale? Can it take bad data inputs, right? The thing I used to enjoy doing, like early on in my career, was just putting a Unicode snowman as text, right? A lot of code is written to be pure ASCII. I was working on doing a lot of Python at the time. Python is awful, or was awful at the time, for kind of focusing on Unicode. You put in a snowman, your code will crash. So that was my way of doing it. And it would always, it's a little thing, but it would check the robustness of the code. But if we're vibe coding, our unit tests become incredibly shallow, right? Is it doing what we want? Security checks that we might have written as unit tests or things like that, because we can do that, those get dropped quite quickly because we don't understand how the code is accepting data from a user. Easy ones for this are kind of cross-site scripting. Hopefully, if you're using a framework, the framework takes care of that. But not everyone understands how frameworks should work. So if you're vibe coding and go, I want a website, is it going to be using the latest front-end framework? Or is it going to be kind of just writing it all in JavaScript? Or do you actually understand the difference between those 2 points? Not everyone does. And it's okay, because like our industry is designing things in a way that we move fast, we break things. The other thing that kind of really crops up, and this is where the human side of things becomes incredibly important. Performance regressions suddenly crop up. No one notices because the code is passing. You have your automated tests, they are passing. No one spots kind of the performance of everything. My favorite thing when I kind of say to people, like when they say, oh, I should automate everything, I go, you shouldn't. Because a good automated test will log into your application, do the thing that it wants. It won't notice that moving from the login page to the next page took 10 seconds. It can't do that, right? Because we go, oh, Selenium's flaky, Puppeteer's flaky, Cypress is flaky, let me add a more timer, more things like that. And again, it's just because we're trying to move as fast as possible in an industry that kind of goes, first to market is best to market. So, as I said, I was going to talk about real-world examples. This one I couldn't show because I was working on something internally. But because I had the underlying knowledge, the underlying craft, I was able to spot the problems, which was, I was trying to create an AI tool to kind of process user data, because I head up the developer relations, and I wanted to go, we've got all this information, we need to see who are people constantly coming back to our meetups, because BrowserStack runs, I think at 400 meetups a year at the moment around the world, constantly growing, and we wanted to just find the people who are constantly coming back, promoting us, doing things like that, so we could send them something nice, right? They're giving to us, we should give back to them. And so I wrote some code, and I said, well, I want to do this. I was vibe coding, and suddenly it was like, and I was doing it all in JavaScript because I was trying to use APIs for a website to pull the data quite quickly. And suddenly I found that I was being able to firstly use non-standard APIs. I worked at Mozilla, I still use Firefox, I don't use Chrome unless I have to. And suddenly, I spotted these things. I also then spotted that I could do an injection of code into the website. Yes, I could be using dev tools, but I could still inject into it to then get past other things to get more data. In this case, I shared the information with the person, and they were like, oh, okay, we'll go fix that. But in this case, they weren't able to recognize the injection case. They just assumed that it's safe because the JavaScript is there. And they were able to patch it. And so this is from a well-known website for doing meetups. The other side of it is code assistants are making more security problems, right? In this case, a security firm said this, right? This is not just me saying it, but they've analyzed, it says at the bottom there, analyzed code from tens of thousands of repositories with several thousand developers at Fortune 50 enterprises. And they're moving fast, they're injecting security problems into their code. Anthropic's CEO last year said that they expect a developer 50% of code to be written by developers, 50% to be written by AI. This year, their belief is that 75% of code will be written by AI. I think we're kind of where we are in the hype cycle is that next year, maybe the year after, we'll hit 100% of AI code. And very shortly afterwards, we'll do a reversal. Because companies will, because hacking and like security problems is not a if statement, it's a when statement, right? And so we'll get to a point where these codes are creating larger problems, getting hacked, people's data being stolen, and then companies being sued for it. Again, this is not your fault. It's not AI's fault either, right? AI is just kind of a decision engine. It tries to figure out where the next bit of code comes from, and it tries its best, and it does really, really well. But if you don't understand the underlying craft, you're in for a bigger problem. The other one is kind of, this one I played around with. And you can do it too, right? Is that if you get, you ask AI to process something, right? Give it a large data set. I'd like you to write some code, right? Because that's what, like AI is not going to process it for you, but it will create other bits of code or other bits of pieces to kind of generate to process it. And again, if you have this prototype, prototypes go into production, rarely changed before they move on. And so in this case, you can do it too. You can just go, generate 1,000 emails, email addresses. Tell it to process it in any way, like sorting, things like that. And a lot of the time, it will go for kind of what it sees other people are doing, because it takes the data that others have done. So it doesn't necessarily generate the most performant code. So in this case, I kind of got it to, there's a typo, n squared algorithm. When kind of it was simple, like the size of the data set should be as quickly as it be processed. Now, going back to my original thing where the person from Replit lost his data, he only had 1,000 records, right? So it wasn't too big, but it was his entire business. 1,000 records, I'm sure we can all agree, in a database is tiny. Is what we would expect, like at a high school level if you're building something just to prove in a computer science class. But we need to be talking kind of billions of rows if you want a large enterprise application. If you're processing anything that comes in at high volume, event data, things like that. And the world is getting into a state where like every year we double the amount of data we collect in it, like as a kind of humanity. So if we're now trying to process this information and we don't understand the fundamentals, we can't scale. The other side of it is that like AI can never be 100% correct, right? OpenAI earlier this year admitted, like they wrote a white paper. This is the news story that came out last month. But earlier this year, they wrote a white paper going, hallucinations are here to stay. We can't get over it. We can't beat the hallucinations. But if you understand why or what is happening, we can get there. My favorite story about hallucinations, I'm sure we've all seen it, is a lawyer in the US was doing his work, got ChatGPT to write up everything he needed, cite case law, things like that, so he could send it to a judge. The judge read it. The judge, in the perfect sense of a tester, went and said, I'm going to check everything. I'm going to go through it. Looked at all the cited case law. None of it existed. The lawyer never even looked it up himself, right? He was like, I've got to hit my billing hours. I've got to do this. I've got to go send it. The judge threw out the case straight away. Said, like, if you're doing this, what else have you done wrong? And so, actually, before I move on, is that like the other side of it is that AI can be poisoned, right? AI prompts can poison a data set in itself because you can kind of manipulate how things are. And we're also getting to a point through MCPs, things like that, where it becomes a lot more dangerous. So, I think this is fairly self-evident, right? We've always been taught that as testers, the sooner you find a bug, the easier it is to resolve. So if a developer, while they're coding, it's an instant fix. If it goes to a tester, it creates a loop, and it's a little bit slower. It gets into kind of a testing environment. It becomes even harder because then you have to think about deploys, right? It gets into production, it's the most expensive point. So, but if you never understand that the technical debt is there, how do you even know how much it's going to cost you later? One of the things that, I'm a big advocate for kind of low-code automation, because I see it as a really good way to get into the industry. You can just low-code, do everything you want. The thing that it always generates is code that can't be maintained. It's getting better, but it's still a long way off from being maintained. And because if you don't have the fundamentals, it becomes technical debt. Now, sometimes it's cheaper just to re-record and go, right? Because you've had a look at it. And I see that a lot in different companies, and I think that is an acceptable way to do it. But if you're trying to scale up your testing, scale up everything, make sure you have this long-term plan, technical debt will kill a company. If you're constantly having to rewrite stuff, I know like Hamza was saying earlier, like a billion tokens is $10. But if you kind of expand the context that a prompt is in, you can blow through that $10 in 10 minutes. Because your prompt is getting bigger and bigger and bigger, right? So like if you go, I'd like this thing, great. This thing is in the wrong place, can you move it, right? It takes the previous thing and this thing and does it. And those like tokens burn through very quickly. And it becomes far more expensive to resolve later, but it can be resolved. Like it's not the end of the world. Now, I was speaking to a colleague. I've just launched a podcast at BrowserStack called BrowserStack Talks. The latest episode, I was talking to a colleague called Dan Makarov. Now, Dan's one of our product managers, super smart guy. And he's described AI in that talk, when we were doing it, about AI being the great averager. So if you don't understand something, it averages you upwards. And that's amazing, right? We get more people understanding things, doing things, moving on, which is great. And his analogy was if you're a musician, right? My wife's a musician. She's brilliant at music. My kids are, because of my wife, are brilliant at music. I can play 3 notes on a piano, right? If I got ChatGPT to compose something for me, it would do something that I would never be able to do. And I think that is amazing because it allows me to open up creativity that I've never had that opportunity to do. The problem is I then can't go put it on a piano and play it. Pick up another instrument, play it. And so if you understand what it was, if I could play the stuff and do that, I'd be a much better musician, right? Because I understand the fundamentals that are below that to be able to do it, and I'd be averaging up again. And moving because with averages, you want everyone to move up. You're not going to have a Beethoven come along and go, let's create music through ChatGPT because they understand the craft, they want to do things, they will do things that have never been done before. We get different types of music, mathematical music, sounds really weird, and then you get really romantic music, that sounds amazing. And so we need to think of going from this crutch where we the tool's going to make me amazing, to actually going, it's a tool. So if we get it to write code for us, get it to test, don't just paste it. Don't just leave it in the code, right? See what it's actually doing. Read it. If it doesn't look right to you or you don't understand it, go learn, understand it. Understand the documentation that it's picking it from. The other problem is ChatGPT might be using old, outdated ways that framework doesn't support anymore. Or when you go to upgrade the framework later on, you've got to rewrite everything. Intentionally make breaking changes so that you can walk through the code. Again, understanding the craft behind it so you can go, oh, it's doing this, it's doing that. Why is it doing this weird looping here? It doesn't need to do that. And then that way, we can all learn, we all move upwards in doing it. We should always dedicate time to understanding the fundamentals, right? I keep repeating that over because I think it's so important. If your tests are flaky and Selenium, one of the key reasons that your tests are flaky is understanding the event loop in the browser. When do things get executed? How do they get executed? When is it going to send network requests to pull more data from the database? Things like that. Understanding that becomes really important, right? In the past, if you were a C++ developer, you had to think about memory management. Then we moved to other languages where we didn't have to think about it. We had garbage collectors that just did our job for us, right? But don't be afraid to kind of use it, see what the problem is, fix it. Or if it generates the code and generates the tests, add another test that you think it probably wouldn't be able to do. Or if it, that doesn't make sense. If you ask AI to fix the test, make sure that it's not rewriting the test, that it actually rewrites the code. I've seen that a lot of the time where people go, fix this test, and then it deletes the test. It's that's not fixing the test, that's deleting the test. Challenge AI, right? It's a tool. For years we had, if you're a .NET developer, when I got started, the tool of choice was always ReSharper to get what I needed, right? And it was very good at making me move fast. but it wasn't always right, and I was able to challenge and kind of learn things better. I think for testers, we need to always focus on the boundaries, right? Wherever code boundaries are, there are bugs. Contracts will be as good as kind of the data that it's expecting. So give it the unexpected. Does it suddenly crash the entire system? If you're using microservices, what happens if you spin up a previous version of that and the front end needs to speak to a previous version, or kind of things like that? Is the backwards compatibility, is the kind of the contracts that everyone understands always up to date, or are we slowly but surely like not understanding what's there? Also, and I know this is contrary to a lot of my talk, is ask AI, if it were to test this, how would it test it? And then go, oh, okay, I hadn't thought of that. I think a lot of our job is nowadays to use our creativity. Humans are amazing creative creatures, right? We created the internet, we've created AI, we've done all of this. We've been able to do all these. Let's get it to do some of the hard work for us. So, in summary, like, AI is just a tool. It's a tool that makes us faster if we understand its limitations, and it allows us to kind of be better at our jobs. We, as an industry, need to master our fundamentals so much. Understand, like, how asynchronicity works, how, like, the language that your company is using to write their application, how is it actually putting these things together? When it when it compiles, what is it doing? Like, one of my favorite languages that I like to play with, it's only playing with, is Rust. And being able to go, with Rust, there's no garbage collection, because like once a variable's run out of its time, it just gets removed, right? And everything is cleaned up. It does all these really cool things. But if you're just going, AI, write me this code in Rust, and you don't understand that, and then you make a change, and it's like, well, I need to actually extend the life of that variable, because Rust has these things called lifetimes. If you don't understand that, you're not going to be able to do it. And build for sustainability, right? Get it, like if you're getting AI to vibe code, like you're vibe coding, get it to do smaller things. Get it to explain why it's doing it, how it's doing it, and then building it out. The more you build for sustainability, and to me, to be sustainable also means writing incredibly boring code, because boring code is easy to read and easy to maintain. You build for sustainability. No one wants to be rewriting things in 6 months. And with that, I've come to the end. It's about 2 minutes, but if there are any questions, if not, I will be at this networking area. You can ask me more questions there.
Okay, thanks, David.
Cool.